Hello everyone and welcome to the first episode of CPP Next. In this series we will talk about C++ subjects, basically a lot of the things that I talk about in LinkedIn, but we will have more time to dig into those examples that I'm showing and understand them much better. All the videos will be on YouTube and on my site CPP Next. So, without further ado, let's start the first episode. The first episode will be called the dreaded comma operator. And yes, it's a very basic subject, but still it's something that is misused and people don't clearly understand. We need to understand why and how to use comma operator correctly and how not to fall into its many pitfalls. So let's start with a simple example. Let's say we have two integers, int a that is equal to 1 and int b that is equal to 0. Then for some unexplainable reason, someone wrote an assignment to b that looks like that, a++, a. Think about it. What will be the answer here? What will be the assigned value of b? What will be returned here? Pause the video for a second and try to understand by yourself. After you will unpause it, I will give you the answer. And the answer is 1. If you decided it's going to be 1, then good. But why? Why did that happen? Basically, it happened because the comma operator has the lowest precedence in all of C++ operators. That means that if you wrote something like that, it's the same as writing this. Basically, we have two different expressions here. One is an expression that actually assigns to b and uses the post increment operator, and the other one is an empty expression. It's a valid expression, but it does nothing. It just calls to a, and that's it. The value goes away. And the b is equal to 1 because we have a post increment expression here. What does it mean to post increment? We read the value from a, we return it to b, and only then we increment. So b will be 1, and we will compile the code and you will see that b will be 1. But a is now equal to 2 because it's actually incremented. And as you can see, that's the reason. So you have to understand that the comma operator, and this is important, has the lowest precedence, and that means that it will be the last operator to work. Now, why should we use it? As you've seen, the comma operator also deducts the order of execution. That means the first one to be executed is expression number 1. Expression number 1 is this. And then, and only then, expression number 2 will be executed. And this will be in this order, not reordered in any way. Many things happen in C++ in the compiler without defined order. For example, if you're calling a function like this, each one of those expressions can be deduced or evaluated in a different time. For instance, the compiler can start with expression number 3, then jump to expression number 1, and only then evaluate expression number 2. But with comma operator, it demands it to be in the order that it's written in. So you still may ask yourself, why do we need it? And the answer is fold expressions. So before C++ 17, and we had actual fold expression, we had to do a little trick with initialization list or something else, but I will show you the trick with initialization list that demanded fold expressions. So let's write a function. Okay, so what do we have here? We have a variadic template function that receives variadic pack of parameters into the function and wants to multiply them all with fold expression instead of using recursive templates. The trick here is that we can use initialization list because we can initialize the list with integers. We could do it with any value. And we're using the comma operator here to do an expression, ignore the first value from the expression, and then set the expression itself in the initialization list to 0. So in the end, we will have an initialization list that will contain only zeros. But because res is a global variable inside the function itself, or a local variable inside the function itself, it will be multiplied by all the values. And because we are using the ellipsis operator, it basically says, please expand all the values, please multiply every one of those, and then set everything to 0. But res itself will be multiplied by all the values as expected. And as you can see, when we use it with x, we are multiplying 1 by 2, which is 2, 2 by 3, which is 6, 6 by 4, it's 24, and that's exactly what we have received. So before C++ 17, that's the way that we could do a fold expression without actually having fold expressions. Now, after C++ 17, and after we got actual fold expressions, this function became much, much easier to write and to read. As you can see, it looks almost the same in the function's signature. But the difference is that we actually have fold expressions here. And that means that we can actually ask for the compiler to do the multiplication without doing any tricks. And it will expand the pack, multiplying value by value from left to right. That's exactly what is written here. It's self-explanatory. It's one-liner, easier to read, easier to maintain. As you can see, we didn't even need the use of the comma operator. So you might ask yourself, do we still need it now when we have C++ 17, C++ 20, and C++ 23? The answer is yes, we still need it. And the reason that we need it is sometimes we need to execute a fold expression on functions. And we need to execute the function on invoke or execute the function on each one of the parameters that are received by order. And to achieve that, we need to use the comma operator. So let's see the example. We will write a hash function. So what do we see here? We have a hash function. This hash function needs to work on multiple values. We want to hash a list of values and not just one value. We have created a very simple hash function that takes the hash value as a reference into the lambda itself. It will work on each x that it receives. And basically what will happen is that because hash v is something that we took as a reference, we will update it outside the lambda as well. So we will take it, we will XOR it with the value that was received into the lambda. We will add x, the value itself, to the hash v value, and then we will add a, b, c, d, e, f. So that's the hash function itself. Then we're invoking the hash function with all the parameters, or basically one parameter at a time, and we are using the comma operator to invoke it one by one. Then we are expanding it with a fold expression. Very similar to the trick that we saw with the initialization list, but here we are using the comma operator because we want to invoke the function on each one of these parameters that we have received to the main function called hash, and calculate the hashing for each one of those by order. So as you can see, after calling this function, we receive this value, 11,326. That's the value that the hash function calculated, but the main reason I'm showing this example is that comma operator is still usable. it is important for if you are trying to use fold expression on functions and you need those functions to work with an order, or even without a special order needed, you will still need to execute it with the comma operator because fold expression needs to work with some kind of operator. So as you see, it's a powerful tool. If it used correctly, it will help you a lot. If you will misuse it or will not understand it, it has many pitfalls, but hopefully after this video, I explained it a little bit better and you will find it very, very useful in your C++ work. Thank you everyone and see you in the next episode.